Hi everyone, my name is Martin and welcome to another great edition of MP Astro. Now imagine you've got your telescope set up. You've got your software for your camera set up, you've got your auto guiding, you've got your mount polar aligned, you've got the telescope balanced properly, and you're taking some awesome images of some deep sky objects, taking long exposures of 5, maybe 10 minutes or so, depending on how long you want to image for and if the sky conditions are good. Now, have you ever had this problem before? So as you can see in that image, you see all these horrible streaks of light crossing the path of your valuable captures, and it ruins the shot completely. And you're wondering yourself, that is, I've just done 5 or 10 minutes exposure time, even more, and these star streaks or satellites are ruining my images. And it really is quite annoying. And to be honest with you, those streaks are Starlink satellites. Now, I'll be honest with you guys and girls, I'm all up for technology. We need to progress to help everyone in this world. I totally get it. We all need Wi-Fi and get access to internet because there are certain parts of the world where you can't gain access to Wi-Fi. And I totally get the reasons behind these Starlink satellites. But what I don't get is, and it makes matters even worse, that yes, these Starlink satellites are outstanding technology, but what I don't get is that these satellites only last up to about 5 or 6 years into space as they orbit around the Earth. So when they do lose the power and all that, and they do actually burn up in the atmosphere slowly. The other thing is, and to be honest with you, his plans are to send 30 to 40,000 of these Starlink satellites, which is great because that means it will do a live coverage of the entire Earth and everyone can gain access to Wi-Fi, which is absolutely awesome. But there is a catch-22 to this. These thousands of satellites are going to cause some massive problems in the long run. Yes, everyone can gain access to internet, but one thing is it going to be free internet? Is it going to be available for the poor people amongst us? I don't think so. Alright, this Wi-Fi connection is very expensive, and to be honest with you, they're going to send loads of these satellites not only to ruin our night skies, alright, it's going to kill our hobby. It's going to kill astrophotography because you've got so many of these things orbiting around. It's already a hindrance with a few thousand. Just can you imagine tens and thousands of these things orbiting around our night sky, totally invading our night sky and totally destroying your captures? It's going to kill astronomy, all right? Plus what it's going to do with these orbiting net satellites, you can imagine thousands of these satellites, it's going to disrupt our lives in the long run. Can you imagine what it's going to do to nature, to wildlife? And can you imagine what it's going to do to us? You're looking into space, you're looking into the night sky, and you see loads of these satellites, bright satellites that are totally dotted across the sky. It's going to really cause some effects to us in a big way, and there must be something they can do about it. And to be honest with you guys and girls, they need to start changing the technology and have these satellites with a huge they've got these used solar panels that are so highly reflective. I know they're trying to do something about it by trying to minimize the reflections, and these reflections are caused with the solar panels. The light from the sun is touching these solar panels, and these solar panels are huge, all right, and these are really big solar panels. And don't forget, there's going to be thousands of these Starlink satellites, and they are absolutely hideous. I'm all for technology. I do like some of the projects this certain individual has produced, and it's absolutely outstanding. I totally get it, but the Starlink satellites are the one thing that really bothers me the most. And the thing is, it's that bad that I get regular shots. I take 5 minutes, 10 minutes exposure, and I guarantee you there'll be 3 or 4 of those satellites that's crossed the path, and it will completely ruin that shot completely. And it really is quite annoying. I know there's a lot of astrophotographers say that you can cancel them out using programs like Kappa clipping, which is a function that you can use in Deep Sky Stacker, for example, where you can stack the images with the Starlink satellite crossings, and this certain app with Deep Sky Stacker can actually cancel out those irritating lines. But the main problem with that is that you do actually lose data, and it does actually make your images a lot less refined. It's also a bigger problem with all the professional telescopes and the professional astronomy, because don't forget, these telescopes are collecting faint light for millions and billions of light years away, and it only takes one of them horrid satellites to cross the path. That data is lost, and they need that data. The data has to be true, okay? Because end of the day, scientists need nothing ruined when they're trying to analyze the data and trying to make awesome discoveries, all right? But these satellites are a big hindrance to our society. So I've been looking around, and I've got loads of telescopes. Some of them are slow, some are very fast telescopes. However, there are certain telescopes I really wish to use, but I can't use it because it's not fast enough. Yes, I do have an 8-inch Quattro with its f4 ratio. It's incredibly fast, but I really need some speed performance to try and capture as much light as possible. And the only way you can do that is use focal reducers. And these focal reducers will help to speed up the light getting collected. Now, I've got refractors, and I do like to take images in mono images. So I have a mono CCD or CMOS camera, and I collect series of images through filters. And these filters are combined with like an LRGB, which is luminance red, green and blue. So I've got narrowband filters as well that I can use. But the main problem is when you've got these horrible satellites that pass us by, if you're taking a certain part of a filter that you want to take apart, it's ruined. And there's times where I've had taken in luminance, even red, green, every single one of them has had a satellite cross the path of that, and I've lost that data. So what I'm looking at is I really want to focus on, I've got a refractor that's got a fantastic setup that I use for mono imaging, and this mono camera is fantastic. It really is. Right, if you've not seen that video, check out the description at the top here. All right, there's a link on there, and I did a product review on that camera. Absolutely fantastic Astro camera. The QHY183 mono camera really is fantastic, but because I need to collect the data as quick as possible, yeah, I'm running into problems with these satellites. These pesky satellites are absolutely annoying. So I need something to speed up my telescope setup to really capture that data much quicker. So then guys and girls, please, before we start, please hit a like button. And again, if you're new to this channel, please subscribe onto my channel. Also, please share this video out, because this video might actually help you, and particularly if you've got a certain telescope that I have in mind, this may actually help you in the process. Like always, I'm going to deliver the goods, show you the evidence as well, to prove to you guys and girls, because I know there's some of us out there don't want to spend too much money in the hobby as it is. But the thing is, you can buy a lot of things into astronomy and it might not work, and you've wasted a ton of money, and that's what you don't want. So in this video, this may help you choose. Again, I can't guarantee this will work on all telescopes, but like I say, I'm prepared to take the risks to help you guys and girls out, and that's what it's all about. This channel, MP Astro, is here to help you guys and girls, so that if this project does work out, you will have the confidence knowing with this help of this video is going to help you achieve what I've achieved. Hopefully, fingers crossed, if this project does work, then fingers crossed, please hit a like button and show your support to MP Astro. Also, do not forget to hit the bell. By hitting that bell will keep you notified for any new videos that when I publish very soon. And believe me, I have loads of videos. I can guarantee you now, you're not going to be disappointed. So, if you're interested on what I'm going to do, please keep watching and let's do this. So as you can see, this is my telescope service 115mm triplet refractor. Alright, so really is a fantastic imaging scope. Alright, very expensive, I totally agree. This is not a cheap item whatsoever. Alright, but you can get these telescopes from Telescope Service. The link I will provide at the bottom. Alright, now this is slightly older variant. I've had this quite some years old, and the new triplet 150mm is has a better focuser than this one. Alright, this is still a pretty good Crayston focuser. Alright, this has got the rail to it, but I believe that the newer ones now have BAADER steel racks, focusers, which are usually I believe 3-inch draw tube, which is pretty massive. This one here, however, is a 2.5-inch focuser. The other one's about 3-inch, I believe, but don't quote me on that. The link is at the bottom. All right, so please check out the description. All right, for this telescope. Very expensive. It's also a very heavy scope as well. It's not the lightest, so believe me, but it's an excellent imaging refractor for what it is, and I love this refractor. Now, the main problem that I have with this telescope is it does have this fantastic photo line 0.79 times focal reducer. All right, now this focal reducer, you can buy this from Telescope Service, but this 0.79 times focal reducer and field flattener, what this enables to do is, this telescope is an f7 focal ratio. This reducer will reduce it down to f5.5, which is pretty fast. Okay, but the thing is, I'm still not satisfied with it. Even though it will speed up the telescope, 5.5 is okay. I can image with it quite well, but there are sometimes I feel that I really want to get it faster. I want to collect the data much quicker. Particular, what I have here is I have a QHY. This is a 183 CMOS Astro camera, and this has a filter wheel system. All right, I've got all my filter wheels. I've got all my filters, which are 1.25 inch, all which, believe it or not, is fantastic little setup, very compact. I've got all the filters I need, including narrowband. So I've got not just the LRGB, but I also have all the narrowband filters as well in this setup. Now this setup here, believe it or not, has got the awesome Amateur Astro 0.6 times reducer and field flattener. Now, really good field flattener. All right, it will speed up that 0.6 times reducer, will speed up this telescope to a staggering f4.2, which is absolutely amazing. I will wish I could get this to work. All right, this setup alone would be perfect. Now f4.2 is pretty fast for a refractor, and there are not many refractors that will be able to, unless you want to spend a ton of money. If you want to spend a ton of money, you can buy refractors at f4, but they are not cheap. So this is a simple solution you can do, is get this Amateur Astro 0.6 times focal reducer and field flattener, and it's a pretty good field flattener as well. But the main problem with this field flattener is you've got to be careful not to use bigger sensors, because if you use bigger sensors, it doesn't quite work at all. But however, this setup will work perfectly with this QHY 183 mono camera. All right, because it's a small sensor. All right, it's only a 1-inch sensor, but it'd be perfect setup for this reducer to work. Now the main problem that I have is that this field flattener and reducer does not work with this telescope, and the main problem is that I don't know what it is. It's really puzzling me. I have no idea what's happened, but it seems like when I try to use this setup, right, this setup here, when I try to connect it to the telescope, okay, you know, it fits in there perfectly. All right, it'll fit in there. Okay, I can remove, yeah, I can move the dust cap on there, right? When I fit it on there, I can fit it right onto the telescope. Okay, all right, and it just, all it does is just slot straight in there. No problem. All right, it slots in there perfectly. Okay, so as you can see there, the whole setup mates onto this telescope perfectly. But the main problem is when I try and focus now, it seems like I just cannot achieve inward focus. There's not enough inward focus with this system, which is a real shame. So there's something not right. I don't know what has happened. All right, it's meant to work with this telescope, but it doesn't. There's not enough inward focus travel enough to achieve focus. So my images are blurred, and if I extend it all the way out, it doesn't work. It seems to seem that I need to somehow reduce the inward focuser a little bit more in order to achieve focus with my telescope setup. So as you can see, I use a program called Field of View Calculator. This is the Astronomy Tools app, which you can actually, if you check out this link at the top, you can gain access to this. Now this Field of View Calculator is absolutely awesome. First off, we're going to imaging mode. We're going to pick out an object we want to view or want to image. So I want M33. M33 is a large galaxy, right? It's probably one of the second largest galaxies in the northern hemisphere. I'm going to find my telescope that I wish to use. And there it is. This is the telescope service. and it's got the focal length of 805 millimeters, 115 millimeters of aperture, and I'm going to pick out the camera I'm going to use, which is my trusty QHY. Where is it? There it is. QHY 183 mono or color. I'm decided to go for mono. As you can see, it's got its resolution and pixel size. Now the pixel size is not really great for this telescope, because what I'm going to do is going to undersample my images with this, with this small pixel size of 2.4, so it's not great. So either undersample or oversample pretty bad. And as you can see here, the ratio is f7 and the resolution there is 0.61. You want to get either 1 or to 2, factor 1 to 2, which is the ideal resolution you want. So we're going to be using a focal reducer, and as you see, the focal reducers, what I'm going to use is a 0.63 times focal reducer. Now as you can see there, we have lowered it to f ratio of 4.4, and the resolution's almost at that perfect 1 degree. Well, the resolution's almost perfect, but as you can see there, you can see it fits perfectly in that frame, as you see. So I want to go lower than that, because I'm using the 0.6 times focal reducer, which is really crucial. Unfortunately, such a reason this app does not cover a 0.6 times reducer, which should be included here, because you know you've got all the other Barlow lenses and all that. So I did work it out, and I actually worked it out that the focal length, I can lower it down to the focal length. What I've worked it out with the 0.6 times focal reducer lowers the telescope to 485 millimeters, which gives me an f ratio of 4.2. And as you can see, the resolution now is at the ideal factor of 1, just over 1. So as you can see there, that's a perfect size of resolution, and we've got a decent frame in there. So we've got the entire galaxy nicely centered and within the sensor, and that's how I've calculated it. So we'll just add that to view, and there you go. So as you can see there, we've got a wider field of view, but the galaxy fits perfectly inside that target. That galaxy fits perfectly inside within the sensor. So that's how I worked it out. It's a real shame that there's no 0.6 times, but I calculated it, and it is literally around about 485 millimeters. Now this is only just a handy tool. This is not going to guarantee if it's going to work. Okay, with this value there, I'll probably be within the limits with this telescope, so I'm not going to over or undersample. This is only a tool. It will give you a rough estimation, but the real deal is when we start imaging. So when we start using this focal reducer, if it works, fingers crossed, we'll have a we're going to have a nice image of M33 without a doubt, and we're not going to be undersampling or oversampling at this point. So as you can see there, within the limits. If this works with a 0.6 times focal reducer, then wish me luck.
So the solution to solve this dilemma I'm having is this. What I've got here is a BAADER ultra short 2-inch eyepiece clamp. Now this eyepiece clamp, part number 2458196, this costs around £77, which is quite expensive for what it is. So I bought this from Telescope Service, and that cost €75 or around about €76. And this adapter, it has a back focus of 12mm, so it's quite short. The adapter can mount onto any Carl Zeiss M68 system thread. It has both sides of the clamp and it's equipped with an M68 male threads. This adapter also allows to integrate a 2-inch clamp into any series of M68 extension tubes or rings. Now if we take a closer look in the box, well packaged, for £77 it's quite expensive. So as we can see here, we'll take a closer look. You can see it's quite a good quality. It's aluminium, CNC machined. I do like there's 3 screws right now. These are M4 screws, all right, and they're well made, all right, stainless steel as well, so they're quite strong. Here you have an M60 thread and an M68 thread on there as well. So using the M60 thread, you'll get a back focus of 17.4mm. Using the 68 thread, you get a back focus of 12.4mm. So it's very short in that respect. Now this ultra short clamp 68 can mount onto any BAADER steel rack and 3.5-inch Hyperion focuses. Depends on your focuser, this adapter will fit as long as it's an M60 or an M68 thread. It also has an internal thread inside here. Okay, so if we unscrew here, you see it has another M68 thread. As you can see there, it's got an M68 thread there. So it's got 2 male ends. All right, and this you can enable to use extension tubes, okay, to screw onto there. So particularly handy if you've got some telescopes, which is a Ritchie Crichton, which has extension tubes. You can use this adapter to mount both sides, okay. So it's a really good clamping system, very well made, very durable. But for what I need for my 150mm triplet refractor, this is going to be a vital part. This is going to be the vital component that I need to achieve my goal. So it's very crucial. But this is the best solution to couple up any heavy equipment, particularly if you've got a filter wheel set with a heavy duty CCD camera on there or a heavy duty CMOS camera. All right, this will fit onto any telescope, providing you've got an M60 or M68 thread. All right, so this adapter, one thing I found out is that these screws are not long enough. All right, because my telescope has a large focuser draw tube. These clamping screws are not long enough, okay. So what we do is we take these off like so. I do like how there's 3 clamping systems and it goes onto a brass annealed ring, which helps to also stops you marring your eyepieces or any of your imaging equipment. Now I've taken those screws off, and the next component that you'll need is a set of stainless steel, and these are stainless steel M4. These are M4 screws, all right, and these are 40mm long. You can get them at 35, but ideally 40mm is probably okay. All right, it's long enough, and these will replace the existing screws. Again, all the links I will provide at the bottom. All right, please check out the description below. I have provided the links for the BAADER ultra short adapter clamp and these screws, and these will just screw on there, M4 thread, okay, quite easily. All right, and these will screw in there. You only need 3 of these. All right, and this will become apparent later on. Okay, so you can get away with 35, 40 is probably the best size that you'll need. All right, so as you can see there, they clamp either way, and you can see where the clamping system, right, it gives a nice tight fit. All right, but you don't need to over tighten these. All right, you just need to thread them on there for the time being. So what we're going to do, we're going to remove this adapter. Now luckily this adapter comes off like so. And as you can see, it takes a while to unscrew it. So this adapter ring comes off, right? This is standard, right? This is pretty standard. Now we will take that out. We do not need it anymore. Obviously we're not going to throw it away. So we're now going to replace the BAADER ultra short adapter clamp, this 2-inch adapter clamp. Now as you can see, if you can see the comparison, this is a lot thinner than this adapter, all right, the standard adapter. So there's too much, it's quite thick, and there's too much there's too much of an air gap there. So with this adapter, we're going to screw in there, and the good thing is it just screws in there, not a problem. All right, so this M68 thread screws all the way in. Now as you can see there, this is the reason why we are using the bigger screws, all right, because you can then tighten up the screws. All right, because of this 2.5-inch draw tube is in the way, there's a flange part that's in the way. And if you use the ones that you get with the adapter, they're in the way. So this flange piece is in the way. All right, so you can't just put these screws on there. So you've got to replace them with these screws. So now, in theory, we can connect our awesome QHY 183M mono camera with its entire filter wheel system. We can just slacken these out, slot it in there, and as you can see, we just tighten up the screws, all 3 screws, and look at that. That is it. That is all you need to do. I do like how it sits nice and flush. All right, it does fit a lot better now. And that is the adaptation. So now, in theory, I've used astronomy tools to work out the calculation on this telescope, and it should adapt this 0.6 times focal reducer and field flattener down to a speed demon f4.2, which is very, very fast. It's literally almost half the focal length of this telescope, just about, but not quite. So for f4.2 is going to make this telescope pretty fast.
So then, guys and girls, we've got the MP ASTRO shed already open, and we've got the telescope set up. So there's my triplet 115mm refractor, and as you can see, we've got the reducer, the 0.6 times reducer there with the adapter, and we've got the QHY 83M mono camera, and we're going to be imaging tonight, hopefully capture some data on a few deep sky objects. I'm looking at imaging M33, which will be a very large galaxy, but what I'm trying to do is trying to get it so that I get the whole galaxy in the
in the actual frame of the sensor. So yeah, I'm using a small sensor, but using the small sensor, using that focal reducer, I should be within the ideal factor of 1, okay, which is a perfect sort of factor to have, because with that factor I'm not going to have my pixels oversampled or undersampled. This is be an ideal factor to have. So ideally you want it between 1 to 2. You will never get a perfect factor, but with this setup, with this 0.6 times focal reducer and field flattener, I should get really fast images, collect that data super quick. Also, I wish to add is that the focus will be very close, okay, and as you can see there, the focus there, there's not much in it, okay, so the focus travel using that field flattener, like I said, I want to bring the focal reducer to come into focus, and as you can see there, we don't have much focus travel with this setup. Now this is a very extreme focal reducer for this setup, but I'm looking at around about f/4.2 ratio, which is pretty fast. Using the QHY mono camera, I'm going to use LRGB, okay, filters for this. So if I'm capturing a deep sky object tonight, I'll be capturing that data super quick. Now remember from my last video, I did actually achieve 180 seconds exposure using a 0.8 times focal reducer of the Bode's Galaxy and the Cigar Galaxy, which is M81 and M82. They're two bright Messier galaxies, and I was capturing that data at 180 seconds, which is pretty quick. Alright, so it's not to be sniffed at. But with this 0.6 times focal reducer, alright, it's going to speed up this telescope no end. So wish me luck, guys and girls. Fingers crossed, and see what happens. Well, guys and girls, after a bit of a setup, a little bit rusty with the new setup. As you can see, I've took a while to go and get used to the QHY 183M. I had to do a star alignment on the mount. It's been a while, but I finally got back in, and I've got it star aligned. And as you can see, if we take a closer look, you see the 6 times focal reducer and reducer has been adjusted, and as you can see, I'm around about 7mm of adjustment there. I've used a focus mask to focus my image of prior, so I used Vega as my main focus to try and focus the stars. I'm now guiding, and I had to redo the alignment again, the star alignment, because I wasn't quite there. And because this QHY 183M has got a very small sensor. However, the good news is if we take a closer look, and I kid you not, if we dim down, we have finally got what we wanted, and as you can see, we have if I just dim that down,
Right, as you can see there, we've got an annoying star trail, which is great. However, looking at the image, we have got M33 Galaxy in a much decent size this time, not just tiny. And I must admit, I'm really impressed with this. And as you can see, I'm only capturing the camera set at 120 seconds, which is 2 minutes exposure time, with a gain of 11 and offset of 103. And as you can see there, we've got some tremendous amount of detail there through the QHY183M, and I must admit, it has absolutely worked a treat. Really is quite impressive. I'm really impressed with the results so far, and I must admit, this is outstanding stuff. Really is. So as you can see there, we've got the setup. I'm really chuffed to bits that this 0.6 times reducer lens, this reducer and flattener, has worked a treat. And as you can see there, we adjusted, and I'm really over the moon, really over the moon. Fantastic result. And again, we need to capture those lights, and first thing I need to do is capture the luminance first, and then get the red, the green and the blue channels. As you can see, with the QHY183M, we're capturing in luminance, and we've got an awesome image of M33 Galaxy. And I must admit, at 120 seconds, there's 2 minutes exposure time with a gain of 11 and offset 103, which proves already that the focal reducer, the 0.6 times focal reducer and field flattener, has sorted it out. And as you can see, even around the edge of the sensor, all the stars are all sharp and pinpointed and focused, so that it's definitely told me that now that is fully adjusted out. It really is impressive. So we've got a lovely image of the galaxy in all its detail, with a decent scale as well, not just a tiny little blob that you usually see, because M33 is a very faint galaxy. Even though it's very large, it is actually quite faint. But 120 seconds is very impressive indeed. And I'm even doing this at 1x1 binning mode. This is in the luminance channel, so I'm getting as maximize as much of the light as possible. When you go through the other filters, you do get a different light spectrum, but this is to capture all the faint detail. And you can see there, you can see the spiral arms and even the center core. But 120 seconds is not to be sniffed at. That is really quick, and we've got some incredible detail there. Really is. As you can see, we've got the camera set up at 20 degrees, minus 20 degrees, and we've got our planner set up. So if I show you the planner, what I'm doing, here's the planner, and what I do, I set up each of the planners 120 seconds. So the first one is the luminance channel, and that is all set again, and then you've got the red, the green and the blue channels. So at the moment it's not much frames, but I'm trying to get as much of the luminance, and then I just collect 25 each of them. I will get up sometime once that's done and then recollect that data again. Alright, try and get as much frames as possible. But as you can see there, it's really impressive so far. We've got some amazing detail for the luminance channel, and look at that, that's just beautiful. Although I'm not quite central, which is a real shame, but we've more or less got all the galaxy in there, all the detail in there. So I'm not quite central, which is a bit of a shame, but look at that detail, it's incredible. 120 seconds is really impressive, really is. And even at 1x1 binning mode as well, that is absolutely amazing. So we keep on capturing that data. I'm really impressed that we've managed to get the 150mm triplet refractor down to f4.2, which is incredibly fast for this telescope. I must admit, really is absolutely outstanding, and I'm not oversampling or undersampling. As you can see, if we zoom in, you can zoom in to have a closer look, and as you can see with the stars here, okay, the stars are nice and pinpointed. That's really good, really good. It's well corrected. This is part of the galaxy. We'll have a look at part of the galaxy. As you can see, yeah, even the center, 3 stars in the center core as well. So we're not oversampled or undersampled in any other way. Though it's a bit grainy, apart from that, I mean, that is absolutely unbelievable. So yeah, we have got a lot of these annoying Starlink satellites which are ruining the shot, which is not great. It's not what I exactly wanted, but hopefully with these annoying Starlight satellites, hopefully they hopefully I can capture some detail without these. Although when you stack the images, you can actually use Sigma, Kappa Sigma in Deep Sky Stacker you could stack the images with these Starlink trails, and then clear it, and then once you stack it, it should cancel them out. But yeah, it is quite annoying with these horrible Starlink satellites. However, I'm not too fussed at the moment, but we've achieved our goal, and we've got the results we wanted. Really, really impressive stuff. So we'll keep capturing that data, and I'm really impressed so far. What can I say? What can I say? So yeah, there's the image there. There's a loads of these satellites. They're absolutely destroying what I'm trying to capture. Hopefully I shouldn't get too many passers by, but you can see what I mean, how bad the problem is with these satellites. You know, you could take hours and hours of exposures, and you know, even just 10 minutes exposure times or something like that, and you've got these annoying trails, and they absolutely just ruin your images. But you see how bad the problem is. And then this is only just 2 minutes exposure time between each of the frames, and I'm getting loads of these horrible satellites ruining the shot. And this is a big problem we're facing at the moment for us astro imagers. You can stack these to cancel them out, but that's not the point. We just, you know, human intervention is ruining our night skies, and things like this is just absolutely terrible. You know, I know for the benefit of technology and trying to help the world become a better place, but seriously, if more of these satellites are sent out every single year, it's just going to ruin our night skies, and that's unacceptable. And as you see there, hopefully we get a clear picture. We have these horrible trailings, but we'll see what we've got. But hopefully the next catcher hasn't got this trail. But it's a good picture. I can still stack it, but hopefully the next, yeah, there you go. So you see what I mean, just between 2 minutes exposure. This is the problem I'm facing at the moment. These annoying satellites, absolutely annoying, and that's why I needed to do this project to speed up my refractor and capture the data as quickly as possible. And you can see between those shots, God knows I've had about 3 or 4 Starlink trails already, and it just shows you that the problem's not going to go away. We need to do something about this, and we need to put a stop to it, because this is not right. This is totally not right, and it's ruining our hobby. And as you see there, I thought I'd highlight this problem. Like you say, this is within space of a few frames, and I've already got loads of them satellites passing by. So, like you say, good results so far, and we've got some incredible detail. Hopefully later on the night, hopefully this galaxy will be much higher up in the sky, and thus avoid these horrible Starlink satellites. So I'll keep on capturing this data, and wish me luck, guys and girls. See if I can get all the channels. Well, guys and girls, what do you reckon? Absolutely fantastic. I must admit, I didn't think it was going to work, and it was a bold move to do that, considering that adapter from BAADER was expensive. It was expensive. €72 is a lot of money for what it is, and I'll be honest with you, good thing with BAADER products, you do pay for quality, and I must admit that adapter has done an amazing job. As you can see in that images there of M33, really is impressive. And the good thing is I've got all the stars nice and pinpoint across the field. Fantastic. I didn't think it was going to work. I'm so impressed that within 2 minutes exposure time I could capture all the channels, the luminance, red, green and blue, all together with a decent amount of data as well. And the good thing is, yes, I did have 1 or 2 Starlink satellites, but because of that, I've not wasted a lot of data in the process. You can use Sigma Kappa clipping, which is a process you can use in Deep Sky Stacker, where you can stack the satellites' star trails in there, and it won't affect the stacking process. But what's the point of that? Because in the day, this problem is not going to go away. In fact, it's going to get much worse. And the thing is, we need to stand our ground and start telling ourselves that this is not acceptable. This is only going to get worse, and it's going to cause some huge problems in the long run. So as you can see, that adapter, I can now use my 0.6 times focal reducer without any dramas. Bear in mind though, depending on your setup, I know that if you've got this type of telescope in particular, the 150mm triplet, it will work for that system. But again, it just depends on several factors. It might not work with certain refractors. I know that the newer variants of this have a uprated focuser. Bear in mind, don't quote me on this, if it's going to work or not, but what I'm trying to say to you guys and girls, give it a try. You can always send the adapter back if it doesn't work. Bear in mind, it's not a well-known adapter, so you might have to order from BAADER directly to get it made for you. There are a few retailers like Telescope Service have them in stock. Robert Valley Optics and First Light Optics will also be able to sell this adapter. But again, it's not a cheap adapter, but again, it gives you that ability to get closer to get that, obviously the focal, you need to get that sensor close enough to enable to achieve focus. Okay, so depending on the focuser, it really does. Low profile focusers, I feel that you might not have a problem with that, but again, it just depends on what telescope you use. And with this refractor, I didn't have enough inward focus travel to enable me to use that 0.6 times focal reducer. Again, please check out Amateur Astro. They sell this 0.6 times focal reducer. I believe it's the only one that is a 0.6 times focal reducer, but by God, what an amazing focal reducer and field flattener. Also, this 0.6 times, I need to highlight to you guys and girls, it might not work very well with the bigger sensors. So if you've got any sensors that are larger than 1 inch, then you might run into problems where all the stars will not get corrected in the field of view. So you might get some vignetting as well, and all the stars will be on the edges, won't be corrected as well. But it does state on the Amateur Astro that it just depends on what focal length you use or focal ratio of that telescope. The 0.6 times works quite well with f7 and f6 ratio refractors. Anything less than that, then the 0.6 times focal reducer might not work out for you guys and girls. So yes, you've got to be careful what you consider this 0.6 times focal reducer. This 0.6 focal reducer, I would say that anything of 1 inch or a 4 or 4/3 sensor size is probably, you'll be okay with that 0.6 times. Anything bigger, like a half crop sensor, like a Canon 600D for example, or anything bigger than that, you might get into problems where all the stars are not going to get corrected in that field of view, and you might get some internal reflections or some weird strange artifacts. So bear in mind, this focal reducer and fill flattener, it does give you much faster ratio, and I must admit, f ratio at f4.2 is fantastic for this telescope. It really is. And as you can see those images, I'm not disappointed without a doubt. But again, I'm capturing all those data with no dramas, with no hassle. I can capture all that luminance, red, green and blue with ease, all right? And with the speed I can collect that data is unreal. 2 minutes exposure time on M33 is not to be sniffed at. 2 minutes exposure time with very little gain, only gain 11, it's not much, but through that QHY 183 mono camera, I've really captured tons of detail there with the nebulosity within that galaxy. It really is awesome. And it just shows you guys and girls that mono astro imaging, using mono cameras, does have its advantage. They're a lot more sensitive than colour, and that's the thing with mono cameras, particularly in the luminous channel. It collects the maximum amount of faint light through that sensor, and you're not restricted what the colour camera does. With the colour camera, it has to go through a Bayer matrix with the red, green and blue channels, and it does it in stages, all right? And with those, it's only a filtered amount of that light is able to pass through that Bayer matrix. Hence the reason why colour cameras tend to be a lot less sensitive than mono cameras. But by God, with colour cameras, they are so much easier than mono cameras. With mono cameras, they are so labour intensive when it comes to stacking and post-processing. It really is a minefield, as it is. With colour camera, you're capturing the data. Once you got your sub frames, then take your dark frames, then take your flat frames. Off your way, stacking, done. With mono imaging, there's a lot more work involved. However, when you put in the effort for that work, you do get better images than a colour camera, and that's the way it is, guys and girls. I know there's going to be a fair few people that tend to disagree with me, but to be honest with you, I like both cameras, and both cameras are damn good. Each one has an advantage and a disadvantage amongst each other. And again, I'm not going to say I favour for the mono camera. I do like the colour cameras because there's certain things, particularly if I got interchangeable weather, or I've got limited dark skies, the colour camera wins big on that. However, with mono imaging, you can image in narrowband when the moon is up. Who cares if you've got the light pollution? When you're using narrowband through a mono camera, it doesn't bother. You will get all that data, not a problem. But again, every camera is different. They all have the advantages and disadvantages. I hope this video has helped you, guys and girls. Please hit a like button, okay? Please show your support to this channel. And again, if you're new to this channel, please subscribe onto my channel. Also, please share this video out, because this adapter might actually help a lot of people that's also considered the 0.6 times focal reducer and field flattener, and they're wondering how they're going to get it to work. Please use this video to help you guys and girls. But again, this is not a foolproof video. I'm not going to guarantee it's going to work for your telescope, but if you're prepared to take the chances like I did, give it a go. If it doesn't work, you can always send the product back. Alright, I'm sure that there are some retailers that will take it in hand. Good retailers will understand that not all telescope equipment are designed to work with certain astral imaging formats or layouts, and good retailers will understand that, providing that you return it in good condition. Hence the reason, keep it in its box. Right, any items that you buy, keep it in a box, keep the original packaging. You can always send it back if it doesn't work. But with that 0.6 times focal reducer and field flattener, it definitely works for refractors between f7 and f6, and providing you're using smaller chip sensor cameras, I don't think you're going to get into problems. But again, please consider that adapter, particularly if you've got this particular model of telescope. Bear in mind, some triplets nowadays, the newer ones of this, come with a different type of focuser, so you might not need the adapter. But again, it's one of those things you've got to try and take the gamble, take the chance. If you want the mega fast super f 4.5 or 4.2 ratio, or even less than that, then please use this video as guidance. So again, don't forget to hit the notifications bell. By hitting that bell, we'll keep you notified for any new videos that I publish out, and believe me, I've got tons of videos coming out. So please hit the bell and you won't miss out. So thanks again, thanks for watching, and I wish you all clear skies.